This is another variation on the mixing tank problem. So a little bit different here, but mostly the same. So we have 8 liters per minute of liquid flowing into a tank, same 8 liters per minute flow rate going out of the tank. The tank has a volume of 700 liters. The difference here is that instead of having a constant concentration of salt flowing in, we have a varying concentration. So it's 2 plus sine of t grams per liter flowing into the tank. And then we also have our initial condition here. Tank is full of fresh water at time t equals 0 minutes, so Q of 0 equals 0. These problems are often very tedious to solve because you have to do integration by parts, and the numbers just get horrible. But here we go. So again, we're going to make the difference equation here. So we have change in grams of salt equals salt going in minus salt going out. Oops. All right, we'll use the units again to make sure we've done this correctly. So change in grams of salt. Okay, well that's dQ dt. Q is in grams, T is in minutes, equals, okay, salt going in. We've got 8 liters per minute flowing in, times, we have a concentration flowing in, it's 2 plus sine of t, so 2 plus sine of t grams, and let me just emphasize that's the whole thing, over liters. And then salt going out, well that's the concentration in the tank, so that's going to be the amount of salt in the tank, Q, over the volume of the tank, which is 700 liters, so that's grams per liter. But then it's flowing out at a certain rate, so that's times 8 liters per minute. Right, so the liters and liters cancel everywhere, so we end up with grams per minute everywhere, so it looks like we've set up the problem correctly. So the simplified problem, dropping all the units, is Q prime is equal to, let's see, multiplying the 8 through, we get 16 plus 8 sine of t minus, that's not going to, well, okay. That does simplify a little. It ends up being 8 over 700 is 2 over 175 Q. All right, so then we can solve this. This isn't a separable equation. We have to use integrating factor, which is why we'll have to end up using integration by parts for the sine of t. So let's go ahead and set that up here. So Q prime, I'm going to move the other Q term over, so plus 2 over 175 Q is equal to 16 plus 8 sine of t. All right. So next step, make the integrating factor. So mu of t equals e. So we have this in the right form, right? It's 1 times q prime. So we have indefinite integral of the thing in front of q. So it's 2 over 175 dt equals just e 2 over 175 t. Right, multiply the whole equation. So we get e 2 over 175 t times q prime plus 2 over 175 e to the 2 over 175 t times q equals e to the 2 over 175 t times, oh, I hope I have enough room, 16 plus 8 sine of t, had to squeeze that in there. Okay, kind of reverse products rule, right? So we have, I'm going to give myself as much room as I can, so e to the 2 over 175 t times q prime equals, left some space for an integral and a dt. So here we have e to the 2 over 175 t times 16 plus 8 sine of t. There we go. Okay. So normally we do integral dt, integral dt. And so this one will get, let's see, e to the 2 over 175 t times q, because the derivative and the integral pretty much cancel, equals, we're not going to do that one. So a lot of, very tedious. I don't think you'll learn anything by me doing it out by hand here. A lot of work. So I just looked up the answer on Wolfram Alpha. Hopefully, if you get a problem like this, the numbers work out a lot nicer, but in general, it's hard for that to happen. Maybe put 1 for everything. But if you do work this out and you solve for the initial condition, what you'll end up getting is, let me just bring that up, this function. So we have 1400 over 30,629 equals negative 30,454 e to the negative 2 over 175t. So you can see that's where that integrating factor is coming in. And then we have part of the stuff from the integration by parts that we had to do with the exponential and the sine term. So apparently that was 2 sine t minus 175 cosine t plus 30,629. All right, so there you have it, and that's how you set up this problem. And then getting to the point where you have to integrate isn't very bad, but actually doing the integration when you have a varying function can actually be very, very tedious. You can get some pretty nasty numbers.